Good morning, good afternoon, good evening. Today we are going to talk on Instana community live for stream Golang tracing AMA. We have exciting discussion today. We have speaker Bastian Kroll and William Carvalho. Bastian is the lead engineer of the Instana and Tracer Engineering Committee. He has been working on Instana since 2018, and he knows the product inside and out. As a member of the W3C distributed tracing work group, he has also contributed important industry initiatives in the observability space. Let's about William. William has experience mostly as a full stack developer, creating widgets and SDK for third party developers. He has spent 10 years as a Java developer. At Instana, William joined as a Node.js tracer team, where he contributed for a bit more than a year for the past year, and half we are been working with Go Live to go. So let's talk about what's agenda for today. We have quick introduction about the Go Tracer and its features. We're going to talk about metrics, profiling, and traces. Second, we are going to show live demo running Go application with following characteristics. As you see here, a small service that receives HTTP requests, it calls another service to retrieve data. And third one, we're going to show the data cached for a couple of seconds in Redis. Third, we are also going to show you a gradually instrument Go application where you could come and see the incoming HTTP traces, HTTP going out request traces, and Redis trace. Uh, I would like to encourage you all to join Instana community. This is the one of the page where you could find all the information. You could find information on customers are sharing information how to do things. So let's say if you're wanting to do something new thing and you think how can I do this, you can post a question, and all IBMers are on this particular website. We could answer you quickly, so it will save you time. With that said, I would love to hand it over to William. William,
Yeah, thank you very much. Uh, yeah, if you could share my screen already and I can start presenting it. Yeah, thank you everyone for joining. Um, I will make a quick introduction about the Go Tracer and present to you a little bit of um, how tracers work in general. So this pretty much applies to every tracer at Instana, but of course focus will be in the Go Tracer. So yeah, as Mangesh already said, I've been working with the Go Tracer for quite a while now, a little bit more than a year. Before that, I was doing some work for the Node.js team, which is also the tracer. And this is quite interesting and relevant for this talk, which is um, the Go Tracer is a little bit different from the majority of the tracers at Instana because it's a compiled language. So we need to do some manual changes in the code. But soon you're going to see these changes are not very intrusive and they are pretty simple. And we have documentations for all of these changes. So uh, yeah, please bear that in mind. Before that, with Node.js, for instance, there is no code that needs to be changed. Everything works out of the box because it's a dynamic language and we can do this. The same for Python and so on. But for Go, there is a little bit of a difference there. So a little bit of an overview about the tracer. It is built on top of open tracing. So all the basics about instrumentation and tracing comes from the Open Tracing API. But most of stuff, it's actually built by us. Open Tracing offers a little bit of code, but also many interfaces that must be implemented. So that's what we do on top of it. So we, of course, collect traces about the application. We also collect metrics about the application. There is an optional profiling and optional events, which we are going to see. For this presentation, I'm going to focus on tracing metrics and profiling. Uh, and So some of the components of the tracer. So this is more or less what you have. If you are already a Instana customer, this is what you have, right? So you have the Instana agent and your application. It doesn't matter if it's Go or not. They should be running both under the same host machine. Typically, this is a pod or something like this. And then the Instana agent is already connected to the Instana backend. So what we do is we have the collector inside the Go application. You need to install this, import into your project, and initialize the collector, which is the main part of the Go tracer. And the collector is going to be connected to the Instana agent. So collector sends data to the agent, and then the agent at some point will send this data to the backend. The backend will at some point stitch together a bunch of information, not only about your application, but also any kind of databases that you're connecting in or any cloud service that you're connecting in, and then everything is going to be displayed together into the UI. So yeah, this is the core package. So the core package offers uh, everything that you can see already, tracing metrics, events, profiling, and connects to the agent, and offers instrumentation to the Go standard library, which is HTTP incoming requests, outgoing requests, and SQL driver. That's what we do from this package. So if you want to instrument something else, let's say a third-party application, a third-party package like Redis or something from AWS, this is a separate package. You can see this as an add-on that you can also import, and it depends on the, the, the core package. And then it provides specific instrumentation for that particular library. So we have a list of libraries that we support. Um, Here in the example, I put InstaGym, InstaRedis. All of them are prefixed with Insta, and you can find all of them in the official Go website, pkggo.dev. And then you can search for InstaGym, InstaRedis, or whatever, and you can see all the content, examples, how to use it, the link to the GitHub repository, because it's also public. And there you can find more details about our packages. So this is pretty much how it works. And then once uh, anything that is instrumented in our application is collected, we send it to the agent, and then, as I said before, the agent will send it to the backend, and everything should be in a few seconds displayed in the UI. So basically, how it works a little bit, if we dig deeper, let's say you have an application, and then you receive an incoming request, an HTTP request, right? So you have a web server running inside of your application. So you receive this incoming request, and you're going to do something with this. Let's say, for instance, you are going to call another service, right? As a second step to this application. And at some point, you also will make a call to a database, right? And all of this information, you give it back to the client who is calling you. So in the tracer side, we have exactly the same thing. For each operation, we have a span, which we call them span. So we have this server HTTP span, a client HTTP span, a database span. We are collecting this. If you have the proper code into your application, by using our SDK, you can collect that thing. And everything, for people used to Go, the way Go stitch together correlates things is based on the context. This is the standard package context, and that's what we use as well. So we need to manually eventually do this if you want to correlate spans. So in this example, you can see the HTTP server span. That's our parent span. This is the first one in the whole process. And then the client call we are doing, this is a child of this span, and the database is also a child. So we have two children for the original span, and that's what we do. We collect this information, and when we have this collection of spans, that's what we call it trace. Sorry. Going a little bit deeper inside of your application, that's what you need to do. So you need to install the packages. So the Go sensor is our core package. You have to have this one. In that example, let's say if you want to instrument Redis, you have to get this third-party package and so on, unless you only need, HTTP requests and SQL driver, uh, then you need to have the extra ones. Then you import these packages, and then you need to initialize our tracer. That's how, once the tracer is initialized, it's going to connect to the agent already. There's a series of environment variables that you have to set. All of these are documented in our documentation page. And then you have this out of the box. So once you do this, once you initialize the tracer, you get already metrics and the connection with the agent, and everything will be sent to the agent from time to time. And then you need to apply changes to your code. So this is a small example for instance, if you have a web server and you have this handle search function, for instance, that's how it would look like. So you call Instana tracing handler func, passing some options there, and it's a wrapper. So pretty much nearly anything that we do is based on wrappers. So if you're familiar with the creator pattern, for instance, that's what we do basically. Uh, and then before we start demo, just because I don't want the code to be too overwhelming to everyone, this is what we're going to do. So for incoming HTTP requests, you have first, that's how your code should look like. And with the change, this is exactly the same as before, right? So you just provide what is in bold. That's the part that you need to add to your code. When it comes to instrumenting outgoing requests, HTTP requests, you should have your HTTP client there. And then we need to use, the way we do it is by providing a round tripper, right? If you're familiar with Go, that's how Go does HTTP requests based on round tripper. So we provide a wrapper around it, and then that's how we can collect information. But that's not it. There's another piece when you're actually doing the request. As you can see there, client resp c.do, we need to provide the context there, and that's where the context comes in, because what we want to do is to properly correlate the original request, the one that your application received. We also pass this context to the outgoing request. So at the end, we can actually see the correlation between them. And last but not least, the Redis is a little bit different. This is, as I said, you need to install another package, which is also provided by us, and it depends on our core module. That's how we do it. It's literally wrap client that you provide, and we do everything underneath with this package. So I want to present to you this quickly now. This is the application I just talked about, and so everything is running on my local machine, but in a real case, you should be running, in a Kubernetes cluster, something like this. The agent should be running there, but everything is running on my machine. So right now, if I go to our dashboard, so I have the agent running in this machine. What we can see is my machine there. So if we click it, you can see information about my machine, right? The CPU usage, memory usage, how many cores, and so on. Memory usage. So all of this information is in regard of my machine. But there's no application running except for the agent itself. And this is just the network interface. Right, so if we start the application now, and bear in mind, the application is not instrumented at all. So if we just run it, then we can actually see what it does. So I would just make a call to this query queue Instana IBM. So what I'm doing here is I'm just forwarding this call to Google, and I retrieve the data and I show it to you. But you can see here cached through, because the first time I call this, I'm trying to retrieve this data from my Redis cache. If it's not there, I'm caching it. So, and the cache lasts for 15 seconds only. So probably if I refresh now, it's false. But if I refresh it again, it's quite quick. And then you can see now it says true, right? So of course we can try anything else here, and you can also see it. First time takes a little while, and then uh, next time it's quite quick, right? And the last feature, let's say, from this application is if you don't provide a query string, you get an error, right? You only see this, but if we look into the actual HTTP request, this is actually a 500. So here it is. So that's what the application does. But everything that I just showed to you, this was not collected by our tracer, right? So what I'm going to do is I will go step by step and do start to see something there. So I'm going to install the sensor first, and now it's there. And now what I'm going to do is I'm going to initialize the tracer. So we can import it. Okay, here it is. And then I can initialize it here. I will provide some basic information here, just the service name. I would just say go sample app. Right. So from this point on, if we run it again and we give it some time, this should not change anything here. It should still work. This should still fail because nothing is there. It's still there. It's still cached. But now you can see something is happening here. So it takes a while because the backend is actually processing lots of information at the same time. So it knows already there's a new process going on. It still doesn't know what it is, but this is actually pretty nice because we can already see that something new is here. Um, and as you can imagine, what happens is because now the application is being the tracer is part of the application. The application is sending data to the agent, and the agent at every 1 second it sends data to the backend, and backend will do something. Now you can see here go app, and then you can see also this is the name I provided, go simple app. So now we have something new, right? So we have some metrics, but this is specifically for this process, for this application. So we can see here some environment variables from Go, the Go max procs, and when the application started, which version of the tracer is being used for this application, and how much memory this application is consuming, what's the activity for the garbage collector, and so on. So Go routines. So it's a little bit different from before, right? Before was the entire machine, but here we can actually see more stuff, right? But that's it for this case. If we try to see something there, if we call this link again, if we make a call to the application, we are not instrumenting it yet because it needs to be manually instrumented. So before I do that, there's something else I want to show you, which is the profiling. So as I said, metrics, you get it for free. Profiling, you have to actually manually enable it. So that's what you need to do. And just to save time, I will already instrument any incoming HTTP request. So that's pretty much a wrapper for this function here, right? So we saw that before. That's the one. We provide the sensor as a reference, the tracer. We need to repeat here the same query and then the function. That's it. If we start this now, so once again, I'll call it. It was not cached. Now it's cached. And just for the sake of it, I want an error. So these three things are there, right? So now it takes a while. that's because I stopped the application. So actually you can do something even cooler there, because now it is supposed to have collected those information. So you can filter this by plenty of ways. The way I'm going to do it by endpoint. So that was a get to query. You can see here, right? These are exactly the three calls I made. The red one, the red dotted one is the one within the error, right? So we can just go here. You can see there was an error. Uh, you can see this is not monitored by Instana because this came from my browser, right? And this call from the browser is obviously not monitored by Instana, so you don't see it, but the destination you do. So this is what we see here. You can see there was an error for this call to the method get query, and then you get internal server error. You get some information here. So if we go to the next one, and that's where it starts to get interesting. You can see both worked, but this one took like almost 800 milliseconds, and this one only 1 millisecond. And you know why, right? Because the data was cached. There was no need to go through the outgoing HTTP request and call Google. So that's why this one is very small. But both of them now, you can see more information here. You can see some details about this trace. So if we, for instance, click here, now we can see what's the host, what was the path, the parameters, and the status was 200. So that's what we want, right? And then we can see it took like 800 milliseconds. So the next one is the same, but it's 1 millisecond. So this is nice. From the developer's perspective, this is quite clear. They know why this took 1 millisecond, but that's not usually the person who's going to check that. And it's not clear why this took that much time, right? It just looks weird. So what we're going to do next is I will instrument the outgoing HTTP request. So for that, here we have our client, and then this is standard goal, right? Transport, but instead of providing some specific round tripper, we can provide our own wrapper here, and then that's it. If you have a round tripper, this is what the new is about, right? So if you had the round tripper before, that's the new one. So you can just, this one will be actually wrapped by our own. So this is the first change I mentioned before. There's another change which we need to do because we want to have the correlation between these spans. So this is where the actual request happens. Uh, so just for you to look into this code quickly. So this is the handle search, right? This is our web server receiving something. And this web server has a context with the content of the span. So I want to pass this through to the other span as well. So here I just created this data from Google One. I'm passing the request here. So what we do here is simply saying with context, and then we can say incoming. That's it. Because this context actually has the information from the parent span. So that's what we need. If we start it again and we do everything over again, I want to test the error as well. It's still happening. This is still happening. This is still happening. So this is okay. Now, again, we need to wait a moment. Yeah, this is the old one. Yeah, I can actually make this 5 minutes only, so we can only see those. It didn't matter. Right, so these are the new ones. I'm not going through this one again because you can see already it's an error, it's there, it's fine. We are actually more interested into this too. So if you go here now, you can see we have 4 subcalls. And then here, something changed, right? Now we have the incoming HTTP request, and we have something interesting. We have more calls than the one I'm actually doing. So that's because the way the round tripper works, it's already doing all kinds of 300-ish HTTP requests. So any kind of redirection and stuff like that, this is already covered by our wrapper. So this is our call. You can see all of them are GET calls. So we can actually see, okay, the original one, we have seen it before. This is HTTP server call. If we go to this, I actually like this view more. That's the right one. If we go here, this is an HTTP call. It went to Google, went to slash search, and all this information. You can see here it's a 302. So that's transparent for me, right? I didn't do this one. So the second call, you can actually see pretty interesting information here from the redirection. And finally, this went through the final thing. And this is a 200. That's what I actually get back. And that's where actually I get the information, right? So this gives us more information, right? To whomever is watching Instana and checking the dashboard, now you can see, you have a better idea why this took 800 milliseconds. And when you go to this one, there's only one subcall. So it tells you something, right? Okay, now I know all of those things didn't happen for some reason, which is still weird why that didn't happen. So because it was cached. So again, the developer knows about it, but not everyone knows. And then as the last piece of the presentation, the demo, I want to instrument the Redis call so we can actually see how it looks like. And by the way, before I forget, we can actually see, oh, oh, no, this is not this is not the right screen. It's fine. So let me do this. I'll stop it again. So for the Redis one, we need to install Redis first because it's a third-party thing. So you do a go get to this package, install Redis. Then we can import it. And that's quite an easy one. In the case of install Redis, it's only, as you saw before, wrap client. So we provide the Redis client and we provide the tracer. That's it. That's all you need to do for Redis. So once again, we can start the application. I will call again with and without cache and the error one for the sake of it. Good. So while this is, okay, we got one already. So while we do this, I just want to quickly go back here, search for my machine. Yeah, so that should be enough time. So I would just search again for those calls. By the endpoint name. Good. Query. Right. So now it should be better. We should be able, now we can see 6 subcalls. Now it looks good, right? Because now we can actually see this is the request I received, and then we try to find the data in the cache. So that's what as members is about. So because it was not there, I went to Google, I did my client HTTP request, I got the data back, I saved this data into my cache, and then displayed the data back to customers, right? If we see the other one, now when we see a little bit more information as well. So what we have is I still get the call, I check the cache, but you can see that that's it, right? Because I had the data into the cache. So this is the best view you can have for the application, and you can, have a better idea what's going on. So yeah, that's it from my side. If you have any questions, or if you want to go back to something that was not clear, just let me know.
Thank you, William. So please, if you have any questions, you can certainly send us an email, or you could log on to Instana community page and you can post your questions on that side. And we'll be happy to answer your any questions if you have any. Thank you very much for joining today's call, and we'll be ending this call. Thank you very much.